For homework this week, you are going to use a PhET simulation to explore the various relationships between variables in gases. There are 3 experiments for you to complete. Experiment number 1 is number of particles versus pressure. Experiment number 2 is temperature versus volume. And experiment number 3 is volume and pressure. For each of these experiments, you're going to evaluate the claim that is being made, make a prediction about the claim, collect your data, graph the data, and then create an argument based on your data. For the first one, I've given you some verbiage to help you start. For the other ones, you should be able to do it after seeing how this is laid out. Let's now look at the simulator. When you open the simulator, you're going to select Ideal, and this is where you will be doing your experiments. If we go back to our homework document, the first experiment will have you evaluate the relationship between the number of particles and the pressure. And the prompt says at a constant temperature, when twice as many particles are present in a given volume, the pressure doubles. So you're trying to evaluate this when twice as many particles, pressure doubles. These don't necessarily have to double each time. You just want to have a lot of data that shows you whether or not the pressure doubles when the number of particles double. It's important that you do a few of the following things. You want to hold the volume constant. And then you're going to choose particles and make sure you choose the same type of particle for the whole experiment. So let's say I want to put in 50 particles at first. I'm going to read the pressure here. You want to let this equilibrate. So as it's moving around, you'll notice that the pressure is changing as the particles are moving. Try and pick something that's in the middle as an average. So I can see that the highest pressure I've seen here is 6.2, and the lowest pressure I've seen is roughly 5.4. So I'm going to pick something in the middle of that, and I'll write that down. Then you're going to redo this. You're going to add or subtract some particles, and you're trying to evaluate this. Twice as many particles, pressure doubles. So you'll need to do a bunch of experiments that show that particles are doubling. So again, you don't necessarily need to do 50, 100. You could do 50, 75, 100, so on and so forth. Then you get a lot of data points that are doubling. You'll need to create a graph using Google Sheets. Make sure that your graph has a nice title and labels. You'll need to do it as a scatter plot with a trend line. And then experiment number 2 is temperature versus volume at constant pressure. When it says at constant anything, that is what you need to go onto this side box here and hold something constant. For this experiment, since it's temperature versus volume, you're going to want to hold the pressure constant with this little V here. So you'll reset your experiment, use the same heavy particles that we were using in the first one, figure out other data points that you want to add here, write down what the constant pressure is, graph, and evaluate. And the last one is volume versus pressure at a constant temperature. So you'll want to hold the temperature constant. So you'll click temperature here. When the volume is increased, the pressure increases proportionally. For this experiment, you'll want to turn on the width where you can see how large it is. And then you can change it by dragging this handle back and forth. The highest you can go is 15, this is nanometers, and the lowest you can go is 5 nanometers. So you'll want to pick some points in between, and you're looking to see if when volumes increase, that pressure increases proportionally. Even though this is not a volume measurement that we are used to, it's okay, it will work. So for each experiment, make sure you reset. And for the last experiment, make sure that you make it small first. Start with the smallest width that you can. Add your 100 heavy particles, hold your temperature constant, and then you can start doing your experiment. You can just move it out, and out. Okay, see what you can find out.